types of waves, that is we started with the regular waves, looked at its characteristics, the properties, the physics behind the different parameters, and then we also went into the wave loads and structures due to regular waves, etc. We also looked at the wave deformation, and then after having good amount of exposure to the behavior of regular waves, we went into understanding what is meant by random waves, their effects, and how do you generate random waves, and how experimental investigations are important. Although you have a numerical facility, numerical, I mean the computer modeling, etc., you have a lot of experimental, I mean numerical modeling, or the facility with the numerical modeling, but then there are several problems for which you need to look at the hydrodynamic testing facilities. In this lecture what I have tried to do is, what is meant by hydrodynamic testing facility, I will try to say what is the purpose of doing it, and then also I will start with the regular waves and then go into random waves, which I have already covered. The basic aspect you already have, but then I will focus more on the testing facilities, and after having an exposure to both of these testing facilities, then I will move on to 3-dimensional waves, and once you have the understanding of 3-dimensional waves, I will go into the mathematical treatment of the 3-dimensional or mathematical representation and treatment of the 3-dimensional waves. So this is what I am trying to, this is how I have organized my lecture on this. For this, Department of Ocean Engineering, IIT Madras has been identified as a center of excellence for the field of ocean engineering, and ever since all these facilities came, I am with the department and I grew with the department. So what I have decided is, I have taken the liberty of using the development of hydrodynamic testing facilities in the Department of Ocean Engineering as a basic material, how such facilities can be developed. This will give you a feeling to the facilities. Not only that, it will also help in some of you tomorrow, if some of you are taking up teaching career and then probably you are planning for your own lab, etc. This gives a good this can form as a good background. So whatever I have I show in this lecture pertains to the Department of Ocean Engineering, IIT Madras. So let me start. When you look at hydrodynamic testing facilities concerning the simulation of ocean waves, all of you have I am sure that most of you would have heard of flumes. Flumes are just facility in any classical civil engineering laboratories. So where you allow flow to take place, measure the velocities or forces due to the flow, all these things, measurement of discharges, all these things have been done, and it would form as an exercise under your BTech program or the undergraduate program. Then this wave flumes are slightly different. It is also the channel, but it has a wave maker at the other end, at one end, and on the other end you have the absorbers. Basically a wave flume would consist of a wave maker which is hinged more or piston more, whatever it is, we will come to those details later. this will be moving up and down. So, this is the water depth and this is the channel in plan. So, your wave maker will move in this direction or it can move in upward direction, it can move in this direction or it can move in this direction. Whichever direction it moves, it results in the displacement of the water surface. Depending on the movement of the wave maker, the water surface also oscillates. Hence, you have the control over the wave maker. So, initially what they did was they used to give simple harmonic motion, in the sense this will be, if it is upward motion up and down motion, this will be from a mean position, it will move up to a certain level, come to this position and go to this position, and again it will go and then come. So, you see that it will be moving up and down like the pendulum of a clock. So, it is going to generate sinusoidal waves. How high it moves, how high it moves, this is what is called as, from the mean position, this is called as eccentricity, or it is also referred to as stroke. The stroke of the wave maker would control the amplitude of the waves, and how frequently it moves, how fast it moves, that controls your wave period. In the initial stages, we just had only a wave maker that was not controlled by any computer. So, we had some kind of a function generator or some kind of a mechanism through which you can control the movement of the wave maker. So, both the stroke of the wave maker as well as the speed with which it moves, that can be controlled. But then there are some kind of limitations, but the system works. Later, due to the rapid development in the computers, what will happen is, what has happened is, this the movement of the control movement of the wave maker can be controlled by computer. How do you do that? You can generate a signal of your desired frequency and amplitude, and this is a digital signal, and digital signal will be generated in the PC, and then this will be having a what is called as a card, which is AD card or DA card or AD card, that is AD is analog to digital and this is digital to analog. So, you create a digital signal, okay, and this signal is now sent through a DA card, and the DA card will dictate the movement of the wave maker. So, it was a pity that some of these components were not available, and so there was a time lag in the developments that took place in other countries compared to the real advanced countries. But now you see that the method has become so simple. Once this method is very clear, digital created in personal computer, have a DA card, send the signal through the DA card, drive the wave maker, and there you have the waves generated in the flume, and once the waves are generated in the flume you need to measure. So for this what do you do? The signal from this one goes to AD card. So you have a DA card to drive the wave maker, it gets the, so you have some kind of a measuring system, maybe a wave gauge or whatever it is, maybe a force transducer or a pressure sensor. Then the signal from this gets into the, through the AD card, and then you acquire the signal in digital form. So this process is clear, but then there is some information which you need to do. When you are doing the acquiring of the data, you need to do calibration of your instruments to convert this oscillation in terms of millimeters or centimeters to I mean convert the signals which you have measured in terms of volts to centimeters or millimeters later. I will bypass that topic because that is going to come under experimental investigations, which I am not going to touch now. So as far as now, as far as this so far said, so again I am repeating, PC, create the signal, send it through the DA card, digital to analog signal, and that signal is sent to the control system of the wave maker, and the control system drives the wave maker according to the signal it has received, and then you can generate the desired signal in the wave tank. Is that clear? So now the other important component is the beach. What is the purpose of beach? So you have on one side beach, one side wave maker. What is this for? When you go and stand on the beach, what do you see? You see the waves breaking, and then you have a gentle uprush. Okay, and you are very sure that the wave is not going to continuously come to you, and that is the reason why you are standing here. So every time you look, you see a new wave coming, a new wave generated, propagates, undergoes transformations which we have seen, and then breaks here, and then you have an uprush. So here the energy is automatically dissipated. So these are, as I mentioned earlier, these are called progressive waves. So in order to generate progressive waves in the lab, we have a beach which absorbs the incident wave energy that is generated by the wave maker. Remember that the waves are constrained within two side walls. This width of the flume can be anywhere between 0.3 meters going all the way to 8 meters. I am talking only about a flume. But it can be much wider also, then we call that as wave basins. I will come to wave basin. Before going to the wave basin, when you look at the wave flume, the waves are propagating. What is the kind of flow you are going to have here? It is a two dimensional flow. There is a flow taking place in this direction, in the direction of wave propagation, plus the oscillation of the, so there is no flow in the direction normal to the board or normal to the flume walls. So this is what, this is how a flume would look like, but then we will try to understand other details as we go when we are talking about how the hydrodynamic testing facilities were developed step by step, so that that gives a better clear understanding. Now what is a wave basin? In the flume you see that the length of the flume is much longer, much longer, many times that of the width of the flume, So basically a flume is going to be available to you to generate unidirectional waves, What does that mean? It means that the waves are approaching the test area from only one direction. So when you are standing near the coast, the direction of the wave, you will see that it is very well defined in most of the cases, because it reaches the coast after undergoing all kinds of transformation, and you will see when the waves are reaching the shoreline, it will be more or less normal, or it can come like this, or it can come like this. So herein the direction is well defined. If it comes like this, we say normal angle of incidence. When it comes like this at an angle, it is termed as oblique wave angle incidence, okay, oblique waves. In the case of basin, so in the case of wave flumes, remember that you can generate only unidirectional waves, but in the case of basins you can achieve this. The size of the basin is either both sides same or one side longer than the other, but it is comparative, it is not like the flume. So the idea is you can generate a variety of waves, not just unidirectional waves. So that means this would certainly fulfill all the requirements for investigating wave structure interaction problems in the ocean. But naturally when you have all kinds of facilities available in a testing facility, naturally it has to be very expensive, not only for installation but also for maintenance. And sometimes it becomes having such a, it might become too ambitious when you start planning for installing a wave basin. Once you install the wave basin, then comes the problem of maintenance also. So I will just go with what are the requirements and what forces us to the facilities, hydrodynamic testing facilities in the Department of Ocean Engineering, IIT Madras, are a wave basin 30 meters cross section and 3 meters deep with multi element wave makers. I will explain that later. First let me list all the facilities. Next is a deep water wave flume 90 meters long, 4 meters wide and 2.5 meters deep. So when I say 3 meters, that is the water depth, and when I say 2.5 meters, it is also the water depth, not the flume depth. Then wave cum current flume, this is 30 meters by 2 meters wide, 30 meters long, and it is 1 meter deep, I have said, but that is the water depth we usually use, but the water depth can vary from about 0.3 meters to about 1 to 1.2 meters, etc. Around 1.2 meters we can still manage. And then we have a shallow water wave flume where it is the length is 72 meters, width is 2 meters, but the water depth can be varied from as low as 0.3 meters and as high as 2 meters. Then we also have a towing tank facility which is used for some resistance tests for ship models, propellers, etc., which I will not be covering that topic much, but this is one of the important facility we have. Then we also have a shallow water basin. Here it is written as in progress, but we have just completed the shallow water wave basin, and then the glass wall flume which is with the flow visualization. So I will cover one by one. But before I cover some of these facilities, let us examine the broad classification of waves that are adopted for testing of structures. Broadly it can be classified as unidirectional and multidirectional waves. Unidirectional, I have just said, the waves approaching your test location from one direction. Multidirectional is the waves approaching your test section from different directions. Unidirectional, you can either have normal wave angle of incidence, which I just now explained, or oblique wave of attack. Again under this category you can either generate regular waves or random waves. There are some reasons why you have to test regular waves, why you need to do with random waves, and why you need to resort to multidirectional waves. First, if you want to understand something about the basic physics of regular waves, or if you are just starting your studies, or you want to just set up a lab, the best way of understanding the basic physics is through regular waves. Testing of coastal and offshore structures in hydrodynamic laboratories with regular sinusoidal waves has been the normal practice for several years, for the simple reason that the physics behind such problems can be very easily understood, because we are going to deal with only one wave. When I say one wave, it means it is a combination of a pair of wave height and wave period. In case of regular wave test, the design wave is represented by a wave period and an associated wave height. The main reason for such test is that the approach is simple in the design analysis, and the determination of the response due to extreme wave conditions such as design sea states is easier. Be it a fixed structure or a floating structure. If you want to look at a floating structure, you can find out the frequency response. For different frequencies, how does it respond, how high it goes, how much it moves forward, how much it moves in the lateral direction. if it is a, and if you are talking about a freely floating body also, how much it can drift. All these informations can be understood. For example, when we are talking about mass transport velocity, remember we were discussing about mass transport velocity. We also said that when we took when we looked at the basic wave hydrodynamics, we said that it is moving in elliptic, circular orbits, and the particle, if you are floating, if some particle is floating, it will remain in the surface at that particular location. But that was not true, you know, that was not true, because if you have a particle here that is subjected to an oscillatory motion, you see that it is getting transported in the direction of wave propagation. When it is moving in the direction of wave propagation, we also found that it is going to be a function of HL square. And we also knew that mass transport velocity will be varying as you go down along the water depth. Now, can you easily can you try to use some simple technique to understand this physics? So, if you have a floating object subjected to regular wave, you use a steeper wave, flatter wave, and then try to find out how fast or how slow it moves near the surface. It is a simple experiment, you can easily understand. You cannot straight away jump into such a problem using a random wave. So, if you want to understand such kind of information, the best way of doing it is with a regular wave. And more so, if you want to look at, this is only an example, if you want to look at the design sea state, then corresponding wave height and wave period are supposed to be used to measure the forces, pressures exerted on the structures. The wave structure interaction phenomena can well be understood with regular wave tests. Whatever I have explained here, if you have some kind of seeds or some kind of flow visualization technique, and if you have a flume, if you have a flume with the side walls full of glass, that will help you to observe the flow behavior, how including the movement of all those things are based on simple linear theory, what we have seen. But if you want to believe and if you want to have a feeling to all those things apart from the mathematical aspect, you can jump into a system. If you have a flow visualization technique, you can visualize everything, and that has to be done only for a regular wave. That is only an example, but there can be a number of serious research works involved in flow visualization technique. There are several complicated problems, and testing the structure with flow visualization and that too with regular wave is quite handy. If this method is applied, the structure has to be tested for several hours, several waves of different frequently amplitude and frequency, and the structure has to be designed for worst load it experiences. That is true. One simple problem here is why when regular wave test, and one more thing is very simple, straightforward. There is absolutely no complications in using a regular wave maker also, even the working also is very simple. So, the last question, if this method is adopted, now you have to subject the structure for several combinations of wave height and wave period in order to find out for which of the combination it might have some problems. So, the testing takes time. Testing certainly takes time, but nevertheless it gives a lot of information as stated through earlier points. So, if you ask me regular wave test, is it necessary or not? Definitely it is necessary. It is very useful, as I have said earlier. Now, random wave tests, why are we talking about random wave tests? Random wave tests are recommended since such a wave simulates large number of harmonic components and its effect can be studied within a short duration, so thus saving considerable testing time. This is also very true. So, when you have a regular wave like this, you have a body, for example, and it is going to oscillate, for example. I am talking only about heave motion. Heave motion is just moving up and down, and I want to find out how the heave response looks like. If I do not have a facility to generate random waves, what I have to do is I have to, so for example, I have to check for about a range of frequencies 0.3, okay, some range of frequencies. Then I have to check for 0.1, then 0.12, 0.14 like this, okay. For complete range of frequencies I have to check how much is the heave for a given wave amplitude. Then I can get some kind of a frequency response or frequency the spectrum, wherein on the x axis I will have frequency, on the y axis I have spectral density, for example, or heave response function. Suppose if you are looking at a structure which is fixed and you are trying to measure the force, so for each frequency I will try to get the for each frequency and amplitude I will get force. So, each wave you have to subject this at least to 10 waves of a particular wave height and wave period. So, when I have about 10 frequencies, 10 discrete frequencies, suppose I have 10 discrete frequencies to cover the range of frequencies which I am supposed to test, then in that case for each of the frequency associated with a wave height I need to generate at least 10 waves. Then you can imagine the number of hours that you put in for the measurement and also for the analysis and coming out with the presentation of the results. But when you look at the random waves, what does that do? Instead of regular wave, I can tune my wave maker in such a way it covers the range of frequencies which I am interested, and then I generate and then I get the force time history, then I subject it both to the spectral analysis as I have said earlier. So, I can have the force, the eta of f and the force. So, in that way I will get how the force varies with the different frequencies. and this kind of a test, it does not take much time, hardly few minutes. What you have spent maybe few hours, a number of hours, you can achieve it in few minutes. Another thing is analysis also is very quite straightforward. For this, only thing is you need a costlier wave maker that will have the facility of generating random waves. Combinations of frequencies may give rise to higher order excitation due to coupling mechanisms. So, this is an observation which you can see when you are testing with random waves, because there can be a particular periodicity which can be contributing more towards the excitation or the force. In many cases, knowledge about these non-linearities may be limited, and test with random waves is the only way to study. So, random waves, but we are talking only, we have been talking only about unidirectional, regular and random waves, have that in mind. In the case of random wave test, the design wave environment considers a wave spectrum, right, because in the earlier class I have said, how do you simulate this? In fact, you simulate this from a known spectrum. This comes from a spectrum, okay. So, energy is spread over a frequency band, that is what I have written here. A suitable wave spectrum model could be chosen representing an appropriate power spectral density distribution of water surface elevation at a site under consideration. This also I have just explained in the previous class, where this has to be considered, that is how it has to be considered, etc. Like you have the standard spectrum from which you simulate the wave elevation of predefined spectral characteristics from which you can measure the forces exerted on the structure. The last one is the wave groups, that is another kind of there are other kinds of waves also. For example, freak waves, when you had H max divided by Hx, I said it will be ranging between 1 to 2, remember that is based on the Rayleigh distribution. Suppose if H by x is greater than 2.0, then we call it as freak waves. Freak waves can create the capsizing of vessels, okay. So, you need to be very careful with this kind of wave. So, the facility, the random wave, the kind of random wave facility can also facilitate testing structures with freak waves. Then wave groups, these are so it moves as a group, wave group. What will happen, the effect of wave groups is, suppose if you are designing a rubble mount structure, the weight of the individual stone is based on weight of the stone is directly proportional to Hs. So, assume that you have designed the stone, and there may not be a problem if wave height is slightly exceeding even the Hs, once in a while it does not matter, but very frequently it exceeds the significant wave height, then what will happen, that is called as wave groups. It keeps on, the wave height is greater than the design significant wave height, but it goes hits at very short intervals, it keeps on hitting, then the stone gets dislodged. These are called as wave groups. such kind of waves can also be tested when you have this kind of random wave testing facility. Now we move on to testing of structures with the multidirectional waves. So far we have seen waves moving in this direction in normal wave normal direction, but what is this 3-dimensional waves? I said when the waves move in this direction, you have orbital velocity in this direction, in the vertical direction, and in the direction of wave propagation. This is the wave propagation, and this is what we have used in our linear wave theory. What did we do? We decided, we assumed that the velocity in the direction normal to the board is 0. We can call it as a transverse velocity. You take an open ocean, somewhere in the deep ocean, the waves are supposed to reach from different direction, it will come from different direction. And if you have a facility to measure eta and the 3 velocities u, w and v, v is the transverse velocity normal to the board, then if you measure in the deep waters, you will see that u and v are almost of same value or comparable. That means that is an indication that waves are coming from different directions at that location. So this kind of a situation is also termed as short crested sea wave, short crested sea, or multidirectional waves. How can you simulate such kind of a wave in a flume? It cannot be done, because there has to be motion normal to the board also. And that is why we resort to 3-dimensional waves or short crested waves. Now you know which is closer to reality, real ocean. Naturally the 3-dimensional waves are close to the real ocean. So now what we have been seeing step by step, we started with regular waves, what is the purpose of regular waves, then what is the purpose of random waves, and then we are slowly going into the reality that is closer to the real ocean waves. But how did this originate? The importance of the 3-dimensional waves. They found that forces on long floating cylinder of arbitrary shape in sway and roll mode, you have motions in we have 3 linear motions and 3 rotational motions. So in the case of roll and sway, they reduce by about 40% due to wave directionality. For example, if you consider the motion in this direction alone, you are overestimating the force. So by considering, if you are considering the structure to be exposed to the action of 3-dimensional waves, then you need to know how it would respond in 3-dimensional waves compared to the 2-dimensional waves, because 3-dimensional waves, when you test, you will easily find that the forces may be much less compared to that in 2-dimensional waves. on the assumption that in the 2-dimensional waves you assume that the force is in the 2-dimensional waves. What will happen if you are considering a square cylinder or rectangular cylinder, when it is moving like this, it is going to be dependent on the width and it is normal angle of incidence. Now if it is moving in this direction, naturally your force is going to be less. So that is what the first point says in terms of long floating structure, cylindrical structure of arbitrary shape in the sway and roll mode reduced by about 40%. Measured values of ratio of largest force maximum to standard deviation were found to be, that is largest wave force, that is the force maximum divided by your standard deviation, it was found to be higher in the long crested waves, where long crested waves means the 2-dimensional waves, short crested waves means 3-dimensional waves. So this is something like 3.9 or close to 4, whereas in short crested waves it was found to be 3. All these things are proved. The added advantage of multidirectional wave or multi-element wave makers, in addition to the generation of multidirectional C state, it can also generate oblique waves. So this will facilitate the testing of structures. Suppose if you have, you want a structure which is floating, I am showing it in plan. So you want to put a structure in plan. So now if you do not know how to calculate the forces and you want to do it through the experiments, then what will happen? If you have only a flume, you can generate only the normal wave angle of incidence, but if you have a basin, then I can allow the waves to penetrate from different directions. So we have seen some few points earlier. Then in continuing the oblique waves, generation of oblique waves is of paramount importance in the simulation of different ship headings and also to measure the forces due to oblique waves on bottom mounted structures, and in which case the bottom mounted structures cannot be rotated. One way of testing the oblique waves is that you have a basin, and you have a wave maker. Okay, this is not, I am not talking about multi-element wave maker, it is a simple unidirectional, it can generate only unidirectional waves, for example. Then in that case I have a structure here and I want to test the structure for different oblique waves, then I can simply rotate the structure. So not with the wave maker will still be generating only regular or random unidirectional waves, but then we cover the problem of oblique waves by rotating the structure. But in certain cases it may not be possible to rotate the structure, and in which case this becomes very handy if the wave maker itself can be controlled in a control room, wherein it is only kind of software with which you need to work, then your model can still be fixed intact as shown here, and then only with the controlling of the wave maker you will be able to generate waves moving in this direction or in this direction. I am talking only about oblique waves here. In addition to the direction waves is something different, but here oblique waves this can be done. You understood? See the purpose and why we need to test have a wave maker. If you have a wave maker that can simulate the oblique waves, then it becomes quite handy. That is what I am trying to stress. So I am sure that this would have given you some information about regular waves, random waves, multidirectional waves, oblique random waves, oblique regular waves. So there is a variety of waves, wave grooves, freak waves, etc. So I will just continue with the facilities that are available in our department, how they were developed or how many years it got developed and what is the status as of now. So this is This will be illustrated with some of the video clips etc., some of the standard some of the important tests which we have done, a few tests I will just project, so that gives you an idea about what is all about. Okay.